Hello everyone, my name is ShiMin and I will be your event supervisor for HUSO Open Solid Earth. So a little bit about me, I am a freshman studying molecular biology and biochemistry at Boston University. I am considering pursuing the pre-med track, but then again, considering. Throughout high school, I did science Olympiad for 3 years, and I did dynamic planet, forensics, chem lab, circuit lab, disease detectives, detector building, among many others. Um, and so this year we're going to be doing tectonics and geological disasters, structural geology, fossil fuels, earth structure and history, connections with fluid earth, and within those topics, we're going to be talking about map interactions and their uses. And if you need any further explanation, most likely you'll find the content within these links. These are what I'm using for the most part to do my research on teaching the content. Science Olympiad is a great website. Any Science Olympiad content for Dynamic Planet Tectonics is pretty useful because this event reflects the official Science Olympiad topic. All right, so today we're going to be talking about the causes of tsunamis and the types and formation of volcanoes. So the major causes of tsunamis are earthquakes. They are generated by movements along fault zones associated with plate boundaries, and they occur under subduction zones where an oceanic plate slides under a continental plate or another younger oceanic plate. So you'd find this near the Ring of Fire, where the plates are constantly moving. You would associate this with any frequent earthquakes. So islands, Pacific Ocean, yeah. So earthquakes, not all earthquakes cause tsunamis. We usually have 4 conditions for it to be considered to cause a tsunami. The first one is that it must occur beneath the ocean or cause materials to slide into the ocean. This displacement of water will let more water come out onto the surface, which causes the wave. Second, the earthquake must be strong and have at least a 6.5 magnitude on the Richter scale. The scale we'll be talking about in the next slide. It's just a measurement or value to measure the strength of earthquakes. Third, the earthquake must rupture the Earth's surface and it must occur at a shallow depth less than 70 kilometers below the surface of the Earth. If it's too deep, it's not going to cause a big enough disturbance. It has to be on the surface so the wave can form. The earthquake must cause vertical movement up the seafloor up to several meters. This is what attributes the tsunami to be so high. And as we were talking about the earthquake magnitudes, the Richter scale is just a representation. It's not, is there a formula? Let's see. So we're gonna restart this. Okay. So the earthquake magnitudes are used to predict tsunamis using the Richter scale. The Richter scale is derived from physics. We are not going to talk about it. We're just going to look at the numbers. So magnitudes below 6.5, they're not likely to cause a tsunami. It's not strong enough. So the wave isn't going to be big enough to be considered a tsunami. Magnitudes between 6.5 and 7.5, the earthquakes of this size are not strong enough to produce really, really terrible tsunamis. You could tell there's like a small wave or like a difference in like the water. And then magnitudes between 7.6 to 7.8, it might produce destructive tsunamis, especially if you're near the epicenter. If you're further away, it might be smaller. Magnitudes of 7.9 and greater, these are usually your worst kind of tsunamis. It is terrible near the epicenter, and you could tell the sea level changes, and there is an aftershock usually. Right. You don't have to memorize this. Just screenshot it or copy it down for reference. There might be a question on this, who knows, but this is good information to have. All right, so the other causes of tsunamis, as you can tell from the graph, 72% is earthquakes. So if you have a limited amount of space or you're trying to memorize lesser information, just know mostly earthquakes and then landslides and volcanic eruption. So landslides are the second highest cause of tsunamis. If it just displaces water along the coast, and then it will disturb the water and then generate a wave to kind of bring back the volume. Underwater landslides also cause tsunamis when the material loosened by the landslide moves violently, pushing the water in front of it. Similarly, the volume displaced from the earth will go into the water, and then the water will come back out towards you in the form of a tsunami. Typically, this has to be a pretty big landslide, though. Volcanic eruption, this is not very common, but it does happen. Volcanic eruptions occur, let's say, near the Ring of Fire. Earthquakes, plate boundary movement, it's related. They also can cause disturbances and then also displace large volumes of water, and as a result, tsunamis. So generally, you would say anything that causes a lot of change in the water or forces the water in a direction will cause a tsunami. Right, so we go to volcanoes. We categorize volcanoes generally into 4 types. So we go back to this slide. There are 4 types of volcanoes. We have the cinder cone volcano, composite volcano, the shield volcano, and the lava dome volcano. So the first type is a cinder cone volcano. It is the simplest type. If you can look at these shapes, it's just a cone. It has a bowl-shaped crater at the surface, and it is pretty short for a volcano, or what you're typically used to. It is built from particles and congealed lava, so like ashes and like cinder, basically, that blows off from the center of the volcano and lands on the edges. So when the lava is blown up, it falls as cinders or like volcanic ash, and it just settles on the top of the cone. So this volcano doesn't rise very high. It's not usually caused by like lava. It's just the particles that settle down. We have the composite volcanoes. This is also called a stratovolcano. This is what you're familiar with, maybe most familiar with. That's Mount Fuji in the picture. It is very tall, it is very steep, and it's formed by alternating layers of lava, then ash, then lava, then ash. And they also have a crater at the center. And at the crater, they have vents. They have one vent or a whole cluster of vents. It depends. And then lava frequently flows through the cracks of the walls of the volcano. So through the center, they will have vents that will allow lava to flow through. And this helps to strengthen the cone of the volcano. And its most unique feature is its conduit system, which is basically like a, you could think of it like pipes or like a whole system, like a chain of tubes or pathways for the lava to flow from the reservoir. And this is unique only to composite volcanoes. Right, and then we have shield volcanoes. These are shield shaped. They're very flat, very low, but they are very, very big. They're very wide, very big, and it's formed by cooled down lava. As lava flows through from the vent, it slowly trickles down to the side and is very, very thin sheets of lava that's cooled down. Sometimes if there are cracks from the vents, lava will also flow through there, but the feature of these shield volcanoes are very, very flat. That's how you would tell them from each other. Okay, and then we have the lava domes. This usually doesn't form on its own. It usually comes into other volcanoes. You can tell by their bulb-like shape. That's why they call domes. When their lava is too viscous or too thick to flow, it's just going to make this bubble shape, and then it just piles around the vent in this like dome-like shape. And then so while the outside cools, the inside is still hot, and then it's going to shatter the outside into fragments or chunks, and then it's going to float on the side. So it's not like a perfect bubble, it's gonna have like particles on the outside, but it is in that general shape, and that's how you characterize it. It typically forms along composite volcanoes or in craters, but it would not be its own volcano typically, right? So just to test your knowledge, we have 4 volcanoes without labels. I give you like a minute to identify them, 30 seconds. Okay, that may have been like 15 seconds, but so we could tell with this top, okay, so the middle bottom, you could tell by its shape, it's flat and it's very wide. So we would say that's a shield volcano, because if it's shield-like shape, the one on the center and at the top, you can see the little, they look like branches in the magma. Those are your composite volcanoes with a conduit system. Those are unique only to composite volcanoes. So that's how you could tell. And then, so we have the composite volcano, and then we have the shield volcano. And the one on the left is like a dome-like shape. We would call it the dome volcano or the lava domes. And then you could tell on the right, it looks like a generic volcano. It's like, it has a cone shape. So that would be our last option, cinder cone volcanoes. So in summary, tsunamis are long, tall waves caused by major disturbances. So this can be from earthquakes, landslides, or even a volcanic eruption. So basically in any situation where a lot of water has been moved and it's going to try to return back, and in doing that, it's going to create a huge wave. And then volcanoes are categorized into 4 categories: cinder cones, composite volcanoes, shield volcanoes, and lava domes. Shield volcanoes are flat, that's how you can tell them apart. And then composite volcanoes have the branching magma paths. They're called conduit systems. And then the cinder cones are your shaped, your general low volcanoes with the regular cone shape, and the lava domes are like dome-like bubbles of magma that's cooled down within other composite volcanoes. Yeah, and so for the next video, we're going to talk about plate tectonics, boundaries, margins, continental drifts, what you typically learned in geology, folds, faults, intrusions, rock types and formations, and layers of the earth. So like we're going to be talking about the earth's crust, its movements, plate tectonics. Yes, and I'll see you guys next